Hello friends, in this video I will talk about how to make a z-test and t-test with an example. So here is the example. In that table, table 1, we have the student rank number and the evaluation score of the 8 students. And these are the scores that the students give to their universities, and it's range from 1 to 10. And you see that the evaluation score of 8 students 9.1, 8.5, 7.2, etc. So here are the questions. Based on that questions, we will make some a z test and a t test, and we will also, of course, show how to check the z table and t table based on the hypothesis test. So the first question: calculate the sample mean and sample standard deviation. This is an example for actually a final exam. So we will just make the results of that questions. Okay, the sample mean and sample standard deviation. First, let's calculate the sample mean and sample standard deviation. So I take the values to an Excel file, but I will calculate a handmade calculation actually. So let me first draw the actually formula of the mean. So remember, for the formula of the mean, we will sum all the values for a variable and divide by the number of the observations, so the sample size. And then I'll find the result as like that. So calculate, take the sum of all observations and divide by the number of the observations is equal to 6.6. Okay, so when I calculate the standard deviation, I'll just subtract the mean from the observations. So also the formula is like that: x I minus x mean, so the square root, the square actually, not the square root, divided by the number of the sample size minus 1 and the square root. If you do not take the square root, it's the variance. If you take the square root, it's standard deviation. So this is the formula. Based on that formula, you can calculate the standard deviation of that variables. So 9.1 minus 6.6 and take the square root. 9 point actually 8.5 minus 6.6, again take the square root. So do it for all those observations and just take the sum, divide by the n number of the observations minus 1 and take the square root. So I will not make all the calculations by hand. I will just show by the exact formula. So standard deviation of that part is 2 point actually 30, so 2.3. Okay, so this is the mean 6.6 and standard deviation 2.3. Let's check the other question. According to the data table 1, can we claim that the evaluation score is above 6 if the population standard deviation is 2? So here the population standard deviation is given. So as we know the population standard deviation, and of course we need to know if its normal distribution is also okay or not. So we also assume that there is a normal distribution. So set up the null and alternative hypothesis and interpret the results. The alpha value, so the type 1 error is 0.05. So how we will set up the hypothesis here? We will make like that. First, we calculated actually the mean and the standard deviation of the sample. So as we have the population standard deviation here, we don't need the sample standard deviation. Population standard deviation is already given. So we'll compare the mean of that evaluation score if it's above 6 or not. Okay, so just I'll have the evaluation score here, and first step I'll write my hypothesis, which is null and alternative hypothesis. Okay, in the alternative hypothesis, as a researcher, I will claim if the mean of the population is higher than 6 or not. And so in the null hypothesis, I will say that if the mean is less than or equal to 6. Okay, so I have a one-tailed test because in the alternative hypothesis I said that the population mean is higher than 6. Step 2, I'll just determine the alpha value. Actually it's given 0.05. Step 3, calculate the test statistic, which is Z statistic here, because we know the population standard deviation. The formula is x mean minus mu 0 divided by the, sorry, not sample standard deviation, but population standard deviation. Population standard deviation divided by the square root of n. So here we know the mean is, sample mean is 6.6 and mu0 is 6 because we will compare the 6.6 by 6 divided by sample standard deviation is given, which is, sorry, population standard deviation is given, which is actually is 2 divided by the square root of n, which is 8. Okay, so I will calculate here 6.6 minus 6, which is 0.6, and I will calculate the lower side of that formula, 2 divided by the square root. So it's karekök in Turkish, but if you use an English Excel, you can just write square root of 8. Okay, 2 divided by square root of 8, which is 0.70, and 0.6 divided by 0.70, and you'll find 0.84. So this is the Z result, which is okay, Z 0.84. You'll check that 0.84 from the Z table. So you will find a p-value and we will find if we can reject the null hypothesis or not. Okay, so let's go to the p-value. Okay, let's open the standard normal Z distribution table. Friends, if you have the Z values with the minus values, you can directly use that table. So in that table, you will just find the exact p-value actually if you have a one-tailed test. Of course, if it's a two-tailed test, again you can use that table, but after finding the p-value here from that table, then you will multiply the p-value that you found on that table. So here we find the result as 0. So plus 0.84. But again, as the standard normal distribution graph is a symmetric graph, again you can use the Z values with the minus values. So whatever the Z value is, if it's positive or negative, or whatever the hypothesis is, if it's two-tailed or one-tailed, you can use the Z table with the negative values. And if it's a one-tail test, then you'll find the exact p-value here. If it's a two-tail test, you'll find the p-value here and multiply by 2. So you can calculate the p-value. So 0.84. For checking the 0.84 from the table, we will first find the 0.8. So the first digit from the column, from that column, and we will follow that row, and we'll find the other digit, the second digit from the table. Okay, 0.04, because it's 0.84. Okay, so we will actually find the 0.84 from that column, 0.04 column, and 0.0, 0.8 and 0.04. So the intersection will give us the p-value, the exact p-value. So it's the p-value is actually 0.20. Okay, from the table we can find the p-value is 0.20. So as we find the p-value as 0.20, we can reject the null hypothesis because the p-value is higher than 0.05. Okay, so when we check the table, we can find that the p-value is higher than 0.05. So we will reject the null hypothesis. We cannot reject the null hypothesis. So we will say that 6.6 is not significantly higher than 6. So we cannot say that the evaluation score is significantly higher than 6 in that example. So friends, how about a t-test? If you do not know the population standard deviation, but if we have the sample standard deviation, then we will make a t-test to find, actually to make the hypothesis test. So according to the data table 1, can we claim that the evaluation score is below 7.5 if the population mean unknown? As we cannot know the population standard deviation, then we will calculate from the sample standard deviation. Set up the null and alternative hypothesis and interpret the results. Again, the alpha value is 0.05. Okay, so here again, we actually calculated the sample standard deviation, which is 2.3, and we calculated the mean, which is 6.6. And here we will just take the evaluation score again. Okay, the mean is 6.6. Sample standard deviation is 2.3. The steps of the hypothesis test is again same. So for the first step, write null and alternative hypothesis. And here's if it asks if the population mean is below 7.5 or not. Okay, so in the null hypothesis we will say that the mean is higher or equal to 7.5. And second step, alpha value, which is here again 0.05. And the third step, calculate the test statistic, which is t value here. The formula is nearly same, x mean minus mu 0 divided by sample standard deviation now, divided by square root of n. So again 6.6 minus 6 divided by 2.3, because we calculated the sample standard deviation as 2.3, divided by square root of n, which is 8. So I'll calculate here 6.6 minus 6, and then 2.3 divided by the square root of n, which is 8, and 0.6 divided by 0.81, which is 0.73. Okay, the t value is 0.73. Here, for checking the t-table, we also need the degrees of freedom. Degrees of freedom is the sample size minus 1, of course, for one sample t-test. Then, as we have one sample here, the degrees of freedom is calculated as n minus 1, which is 8 minus 1, and which is equal to 7. So in the t-table, we will find the degrees of freedom part, and we will also check the actually t value that we calculated here. We cannot find the exact p-value on the t-table, but we can find the the p-value between 0.05 or higher than 0.05, etc. So we can find the result of p-value for the t-table. Here, as we find the degrees of freedom as 7, okay, we will check that row. And as the result is 0.73 here, so I'll come to the table. I will find 0.73, 0.71, 0.89. So it's a result here, which is 0.73. Okay. So on the top you will find for one tail test the p-values, for two tail test the p-values. As we have a one tail test, because we say in the alternative hypothesis the mean is less than 7.5, in null hypothesis the mean is higher than. Okay, if it's a higher or less or small, then we will use the one tail. If it's different or not equal, then we will use a two tail test. You'll check the expression of the question actually. So if in the question it asks you if that value is less than or smaller than or higher than, then we'll set up a one tail test. If it says that if the value is different than something, then you'll build actually a two tail test. Here we have a one tail test. So we find for the t value, as it's 0.73, then it's a value between 0.71 and 0.89, and so the p value will be between 0.25 and 0.20. So the p value is higher than 0.20, less than 0.25. Okay, p value is higher than 0.20, it's less than 0.25. So we cannot find the exact p-value. The table do not give us the exact p-value, but actually we don't need the exact p-value. Here we find that the p-value is higher than 0.20, so it's actually higher than, of course, 0.05. Okay, so again, as the p-value is not higher than is not less than 0.05, we cannot reject the null hypothesis. We will say that the mean, which is 6.6, is not significantly less than 7.5. Okay, so we cannot reject the null hypothesis in the example. Here's another example for the t-test actually. A data with 20 observations has a sample mean of 12 and standard deviation of 2.5. Can we claim that the sample mean is significantly smaller than 13.5? Set up hypothesis and interpret the results. Here we do not have a data, but the data results are given to us. So here I'll open a new section with the 20 observations. We find the mean is equal to 12 sample mean. The sample standard deviation is equal to 2.5, and can we claim the sample mean is significantly smaller than 13.5? So the mu 0 is 13.5. Okay, so again, just set the hypothesis, null and alternative hypothesis. In the alternative hypothesis, we will say that the mean is significantly smaller than. So we will say smaller than 13.5. So in the null hypothesis, we will say it's higher than or equal 13.5. Okay, the alpha value is given again, which is 0.01 now, and we'll calculate the t statistic because we do not know the population standard deviation, but we know the sample standard deviation. X mean, which is 12 minus 13.5 divided by 2.5 divided square root of n, which is 20, and I'll calculate here 12 minus 13.5 and 2.5 divided by square root of 20. Okay, and minus 1.5 divided by 0.55, which is minus 2.68. Okay, we will check that result from the t table, but we also need to find the degrees of freedom, which is here equal to 20 minus 1, 20 minus 1, and 19. Okay, so I'll go to the t table, find the 19 actually row, and also try to find 2.68. So even the t value is a negative or positive value, again we will check here. So we'll take the actually positive value of the t, and 2.68, 2.09, 2.5, 2.8. So the value is a value between 2.5 and 2.8. When we go to the results, it's a one-tailed test, so the p-value is between 0.01 and 0.05. So we find that the p-value is less than 0.05, higher than 0.005, and the p-value is less than 0.01, it's higher than 0.005. So we exactly know that the p-value is less than 0.01, so we can reject the null hypothesis here, which means that the population mean is significantly smaller than 13.5. Okay, so when we check the t table, we need to be careful about the degrees of freedom. You'll find the degrees of freedom first, then based on the hypothesis test, one-tailed or two-tailed, then you will check that one-tail row or two tails row, and you'll find a p-value between two different values. You cannot find the exact p-value. Of course, if you use any actually calculator, Excel or SPSS or any other tool, then it will give you the exact p-value. But when you may try to find from the table, it's not possible to find an exact p-value because the table cannot give for every possible t results actually, because the t distribution is based on the actual sample size. So it's not possible to create a table based on every different t values. So we will find a value between some p values, but it's okay because we actually try to find if the p value is less than or higher than the alpha value.